So in this section, we're going to be looking at transformations of functions. And so I want to go ahead and start out here and say, if of any of all the notes that we have taken, if there is one set of notes that is beneficial as we work through this section, especially in the homework, and kind of processing and digesting what's going on here, this set of notes is going to be the most helpful. So I'm going to talk about a lot of things in here, but at the end of this section, I am going to summarize it and kind of show you what to expect in a testing situation. But in the homework, I'm kind of restrained with the textbook and the online homework is doing. So I do want to emphasize, and I'll mark it as we go in the notes, of things that you're going to need to complete details of homework assignments, because I don't really have any control over taking or putting in details in bulk assignments. Okay, so just kind of know that beforehand. But what we're going to be looking at is, you'll notice in the previous unit, in 3 of those sections, that we did parent functions. And we talked about parent functions and what their equations were and what the graphs looks like. And we looked at their domain and their range and where are they increasing, where are they decreasing. And we looked at all these detailed parent functions. And we did all that because of this section right here. Okay, so when we're looking at this, what we're going to be looking at is, we're going to say, okay, how did we take a parent function and move it around, change things up, and how did it go from a parent function to this new function? And so we're going to break it down into different parts. So first part is shifts. And so we have 2 different kinds of shifts. We have a vertical shift and a horizontal shift. When you're looking at a vertical shift, you're looking at taking the entire function and adding k to it, k being some constant. Adding 4, adding 12, subtracting 2, subtracting 10, because this could be a negative as well. And this means a shift of k units either up or down, just depending on the sign of that k value. So if you'll notice here, 1, this is your parent function, the cube root of x. And notice if I just take f of x and I add 1 to it, basically adding 1 to all the y values, it shifted every single point 1 unit up. And so it said, notice this is a vertical shift of k equal to 1 of the cube root function. So there was a reason that I emphasized in 3 sections in Unit 1's all these parent functions, so that you could understand where would we be starting with and where would we be going. So let's look at an example, because really I'm going to show you these definitions of f of x plus k, but it makes more sense as we kind of work with some values. So it says, if the formula y equals x cubed is changed by adding 7, shown in red, but I'm in black and white here, what effect would the change have on the function's values? Well, the first question says, notice if we do x cubed plus 7, then this is going to add 7 to all y values. We just talked about that in that previous problem where you take all your y values and shift them up 7 units. What effect would it have on the graph? Well, this has an effect of shift all points 7 units up. And so at the end of the day, what do I want you to know? I want you to understand that this number that's being added on the outside of the function, or to the parent function, that it moves it up and down. If it's addition, it's going up. If it's subtraction, it's going down. And again, at the end of this section, I'm going to kind of put all of these concepts together. So let's look at the next one. Horizontal shift. Notice now the shift is inside of the f of x, and that's going to move it left and right. And I'm going to tell you, it's going to be the opposite of what you think. The opposite of what you think. And so say I had the equation like x minus 2 squared. It's changing by 2. Notice it's inside the parentheses where this is outside of it. So it is going to move it 2 units. But you might assume left because it's negative. But because there's a negative in the formula, we're just going to do 2 units to the right. So because there's a negative existing here, that's why it kind of changes it up here. Say I had x plus 1 squared. Well, that would move me 1 unit, opposite of what you think, so to the left. And let me show you what that looks like on a graph, because I think that kind of clears up what you're doing with it. So again, you'll notice it's the same cubic function. There's my parent function. And they added 1 inside of the parentheses, so it moved everything to the left one. So it says, note that your h is +1 shifts to the left, that is towards negative values of x. And that goes back to, we looked at f of x minus h. So if I'm looking at x plus 1, the h value would be -1 because this negative comes from kind of our form. And so again, let's do an example of just what it's given. If the formula x cubed is changed by adding 2 as shown in red, so adding 2 inside, what values would be most directly affected by this change? And so the drop downs that it would give you, we would choose the one that says directly affect your x values. More importantly, what effect would it have on the graph? We would select that it shifts all points left 2. So again, it's going to be the opposite of what you think. And here at the end, I'm going to show you kind of a summary, putting together all these different shifts and transformations. So we've got a vertical shift. We've got a horizontal shift. Let's look at reflection. Now, when you're looking at a reflection, the book does separate it into vertical reflection, horizontal reflection, based on if you have a negative on the outside or a negative on the inside. Similar to our vertical shift was adding on the outside, horizontal shift was adding on the inside. So I do want you to be aware of the differences. You can see here, here's my graph, and a vertical reflection was down here. A horizontal reflection reflected this way. So I want you to understand the differences between the two. But then again, at the end of the day, I want you to just recognize that the negative within that function there, whether on the outside to the whole function or on the inside, it is causing a reflection of the graph. And then lastly, we're going to be looking at the compression and stretches. Now again, the homework, like I mentioned at the very beginning of this lecture, the homework has you click and select, given this function, where is it a vertical shift, where is it a vertical compression? For me specifically, and in this testing situation, I am not going to make you narrow it down to vertical stretch or vertical compression. I'm just going to want you to know that it is a stretch / compression. I want you to know that that width is changing. And so for your homework, you are going to have to know these differences here. And it says if a is greater than 1, so what we're doing is we're taking an a value and multiplying it times our function. If it's larger than 1, then it's stretched. If it's between 0 and 1, so it's a fraction, it's compressed. And if it's less than 1, that means that you had a stretch or compression with a vertical reflection. So what they do is they don't consider negatives in this. That was the previous page in reflections. They're saying number bigger than 1, it's a stretch. A fraction between 0 and 1, that's compressed. And so let me show you what that looks like here, because a picture really helps. So here's my f of x function. If I multiply by 2, a number larger than 1, we get this graph here, which is a stretch. If I multiply by 0.5, which is a number between 0 and 1, we get a compression of it. Still maintains the same shape, but you can see it's been stretched or compressed. And so, again, you're going to have to know this to get you through the stretched and compressed with vertical in the homework. But at the end of the day, I'm just going to need you to know and recognize that that A did a stretch / compression, and that's how I'll word it on your exam. Now you also have horizontal like we did the last two. So again, this is what you're going to need to work as you work through the homework, those specific details. And so now they say if we have f of b of x, meaning you have the value being multiplied within, then if it's greater than 1, it's compressed. If it's between 0 and 1, like a fraction, it's been stretched. And so again, you basically just have your width changing. And again, I'm not going to narrow it down, and you're going to have to know a difference between a horizontal compression or a vertical stretch. But I'm wanting you to understand that adding a multiplier in there or on the outside of it is going to stretch or compress it. So I know I went really quick through all that. So make notes of the things you're going to have to use as you're doing details of homework. But here's the summary, and here's how I want to address this with you. I want you to understand that this value on the outside is moving it up and down. I want you to understand that this h on the inside is moving it left and right. and it's the opposite of what you think. I want you to know that this is causing a reflection, that negative. And I want you to know that this A on the inside or outside, which cause a stretch / compression. So at the end of the day, when you're trying to sum all this up and you're trying to get ready for the exam, this is how I'm going to approach it. I'm going to say, given this problem, what happened to it? And you're going to have to select all that applied. Did it reflect? Did it move left? Did it move right? Did it move up? Did it move down? Did it have a stretch / compression? So I'm not going to make you go down in detail and say it's a horizontal compression by 0.2. But I will want you to recognize what that value is doing that's being a multiplier on the outside of it. So of all the notes that we've taken, I definitely would either print these off or write down these details as you're working the homework, because it's going to go in detail and ask you for those different parts. But in studying for the exam, make sure you understand how to work it from here. And let me do one with numeric values. If you were given something like this, you would have to tell me that it has been reflected. That's that negative right there. That it had a stretch / compression. And that's because of that 2 right there. That it moved 4 units left. That's because of that 4, and it's the opposite of what you think. And that it went 6 units down. And that's because of that -6. So this is how you're going to be posed with a question in terms of the exam, putting together all those transformations. And again, it goes back to your parent functions. So if you missed number 1 on the test, you forgot about your parent functions, now is the time to make sure you understand those, because we're going to be manipulating them as we go forward. So go and try the homework, see what you can do with it. Feel free to holler at me, send me a Canvas message, let me know what you're struggling with or what I can give you further explanation of.